Hi everyone, this is Toby from Team BorgerBots doing a quick design and assembly overview of Killtacular, a 150 gram fairyweight overhead Thwackbot that was inspired by the heavyweight Overkill from the classic BattleBots era. This is the first fairyweight I've made for combat robotics, and it competed at the July 2022 Arizona Robotic Combat Robo Rumble event. Did not do well in combat. Put on a good show, though, and went home with the coolest looking robot award. So, pretty nice trophy. Anyways, I did get a lot of comments at the event and questions asking about how everything fit in it. So, I figured I'd just go over that really quick. So, this is what I like to call the core. And again, most of this is pre-assembled. Just did the boring stuff off camera. But this is the whole robot, essentially. We have a Malenki Nano dual ESC and receiver hidden under the electrical tape there. And that is getting power from the 180 milliamp 7.4 volt 2-cell LiPo that's tucked in the back. Wires run up through the FingerTech mini power switch into the Malenki, and then that drives the two N10 motors on either side of the robot. Now, why N10 and not N20? Well, this robot was very overweight for most of its life and needed to make some drastic weight cuts. That'll be more evident later. A lot of that came back to hurt the robot in the end, but it still looked cool. So these N10s are just mounted using the two tiny, I don't even remember what these are, 156 screws. Not recommended. These come out really easy. They're just screwed into the existing tapped holes in the faceplates of the motors, the gearbox. They do make clamps that clamp down in other ways. I'd probably explore those before doing the faceplate mount. These did not work well. Other than that, I have a version of this without the electronics in it. It is damaged from one of the fights, but you can see this is the print. So this is where the ESC goes. Power switch, one motor. Here's the remains of another motor and the weapon strike that got rid of the other half of this motor. And then the battery tucks in here. I do have electrical tape holding down some nuts that kept falling out. Probably could have designed a better way to keep those in, but it was midnight before the event and I just needed something to hold those in. So electrical tape did the job. So with this core, this is effectively all you would need to strip the robot down to service it. The rest of the body here, I've already assembled. This is the axe, and I've already got a safety cover on it. Safety first. This has two screw holes in it. I've got a second one here. So those bolts are just running through those two screw holes and into the outer shell. I have this white reinforcement collar around it because the way this is printed, and I've got another one here. Thank you, Intensity, for the sizable hole. But with 3D printing, you want to be conscious of your layer lines. And this is printed standing up. So the layer lines are running this way. And all the force of the hammer would eventually shear this in half if it cuts through the layer lines. So the white collar is printed in a way, then let's see if this will show up on camera. The layer lines are perpendicular to the layer lines on the shell. So that just provides some reinforcement. And then the Nylox and the M3 button heads kind of squeeze everything together and hold that hammer in there. So you got the shell assembled. And then this is the wedge. I've already got one of the retaining rings on there. The retaining rings are simple little prints, very thin. Just have two M2 nuts pressed into them. This is more of the lightweighting that had to happen last minute. This used to be solid, like this. But I needed to cut 2 grams from somewhere. So this is only 0.8 millimeters of floor layers and then 2 wall passes, and I'm running a 0.4 millimeter nozzle, so 0.8 millimeters. A lot of this robot only has two printed walls. Again, it made weight, but didn't do well in a fight. So this just goes into the wedge, like so. Just plugs right in. And then there are two tiny M2 by 8 socket head screws. So let's see. Woo! This is going to be the fun part. And through the magic of doing that off camera, we now have both of the retaining rings on the wedge. Should note, anything in black on this robot is printed in ABS, because ABS is lighter than PLA. And that was another one of the changes that had to be made to make weight. Anything in white is still PLA. So to mate these two together, just flex the rings apart and it snaps in. I'll bring out the old ring to show. I don't know if it shows up on camera, but these have a triangular internal cross section. If that shows the angle. And that is what's riding on the body. There's grooves on the outside of the body that these nest onto. Keeps it from shifting side to side. And it can rotate really freely. There's very little friction there. So now, most Thwackbots don't do rings around the outside. They attach them to the drive axle. But because of weight distribution and size, the drive motors cannot be centered, so they're off axis. So, to account for that, the wheel system is an internal gear system. So, small gear goes on the drive gear, and then the wheels here have an internal gear on the inside. These wheels are custom made. The white is PLA again. Originally, they were going to be TPU, and they probably should have been TPU, but I was concerned that the squishiness of TPU would make the teeth slip. Yeah, when these took hits, they just shattered, so TPU probably would have been the way to go. But they had a plastic bushing pressed into them, and these would ride on this M4 shoulder bolt, which would then go in the center of the body to center the wheels again. Now, obviously, with this gear in the way, you can't mount the wedge off the center axle, so that's why it's off of the body. Now, this is the fun part. I'm going to take that gear off. To mate the outer shell with the actual robot, orientation is important here. They are slotted together like so. And this takes a little bit of force. Thank you, tolerances. But pinching wires. Gotta watch out for that. And that totally didn't take 3 more minutes. Always double check your print tolerances. Anyways, power switch is aligned. They're kind of covered up, but these are the 2 LEDs and the Malinky for power and receiver linked. So those shine through the top of the robot, depending on your definition of top. Symmetrical both ways, which makes this hard to drive. But now the core is fully slotted into the body. And you can see the flange on one side has now, and it's kind of hard to see, but it's fully captured the wedge ring. So now we just need to cap off the other end of the robot. So that starts with, put the gear on, and then here is the printed cap. This just drops on over top like that. And then you have 3 little M3 by 8 socket head screws that all find their way into the body of the robot. And because this video is almost 10 minutes long already, I'm not going to make you sit through me tightening 3 screws. Those are on, so now the ring is fully retained, stuck on the robot. All that is left is the last drive wheel. So just put the shoulder bolt in there. There used to be a spacer that kind of stood off from this and kept things square, but again, cut things for weight. totally didn't make the wheels wobbly after the fact. It did. I needed that spacer. That's the wrong tool. This is the right tool. But yeah, you just tighten the wheel on. You can see what I'm doing totally. And there we go. Assembled robot. You can take your safety off. Assembled robot. And then you can get to thwacking.